Good luck out there, buddy. Gonna need it.
Barney, I love you, Barney. Barney, please. Barney, no! This is totally how you're supposed to play the game. I've been learning a lot about, like, garbage collectors, and specifically, like, tricolor garbage collectors. I'm trying to make an interpretive programming language. I'm developing an interpretive programming language, and I want to have a garbage collector, and so I also do manual memory management with reference counting. And even then, reference counting, it's unreliable for like self-referential and dead objects referencing other dead objects with no reference from an alive object. I've been looking like at the Lua garbage collector a lot because I wanted to see how it implemented it. And I've been like taking notes on both like garbage collectors, tricolor garbage collectors, and the Lua garbage collector. And yeah, they're really... Sorry, what the fuck is that? Oh, that's fine. Yeah, I know where yeah. And I've actually like implemented a very simple and poorly optimized mark and sweep garbage collector in an environment similar to Crescent, which is the language I'm working on. And it works, but yeah, there's no like different set. It's just like traverse the main thread, stuff like that, traverse all objects in that main thread, and then go through the entire object list, and like if it's not marked, then delete it, which is very obviously inefficient. One issue I've had is like with like pointers, because like with different sets, you want to have like different lists of objects in each set, rather than having to traverse the entire list of collectible objects. And a really good way to do that is through linked lists, where you have like a pointer to the actual next object instead of them being like sequentially right next to each other in memory. And it would be easy to do that if the garbage collector implementation that I'm trying to go for actually had a previous link to the previous one. And the reason I don't want to add it is because I've seen that the Lua garbage collector doesn't have that, and there's probably a more efficient way, or like smarter way, of moving between sets that Lua's doing that I couldn't come up with myself. So I'm trying to look into how it does that with no previous pointer, but I can't really figure it out. But that's probably the only issue I've had with that. Something I another thing that I don't understand about the Lua garbage collector is there's this union called a GC value, or no, sorry, GC object, and it's a union, and in that union is the GC header, and then the actual all possible collectible type bodies. And I've tried implementing that, but what it does is it just causes a bunch of like cyclical reference issues, or like, yeah, or like circular reference issues where like object requires GC value, but GC value requires a type like array, but array requires a type like object. And I don't want to have to like forward declare GC object because that seems it's not really that clean. And even though it's a pointer, which will make it valid, it's just doesn't. There's a better way to do it. And what I found works better is using the GC header itself. So to convert, so with the GC object, to convert a header to a type body, you would have to cast the header to a GC value, and then index the union of the actual type. So it cast index. But with GC header, all you have to do is actually just cast it to the type. And this is valid because, oh, for fuck's sake. And this is valid because all type bodies would start their definition with the GC header. And the offset of the first member of a struct is always 0 bytes. So you can, yeah, you can just, so the pointer to the first member of struct and the pointer to the struct is the same address. So I don't know why Lua uses the GC object union. Seems like not that good of a way of doing things, but like there's a lot of mysteries in the Lua source code. And it's actually kind of surprising how fast Lua runs, like looking at the source code. It's like all over the place, and I get like Lua was developed over the course of 30 years and is still being developed, but like, oh my god. And maybe my code is like that too, and I just don't know because like I wrote it and I understand like where everything is and how it is, but like it can't be. A large reason I haven't been working on Crescent a lot lately is because like the code is really messy right now, and to fix it I have to like add a bunch of stuff or like change a bunch of stuff. Oh, okay, that's weird. I don't know what the fuck that was, but and the things that I want to change would actually make the code even messier if I don't implement the garbage collector while I add them. So I have to do that before I work on anything else. Oh, you can sprint while crouching now. Oh. Oh yeah, I wanted to change, I wanted to restructure function calls and or like protected calls. And functionally they would work the same, but they would be way better internally. Because I currently, protected call is actually segmentation fault if there's an error, so that's not the best. Actually, and by not the best, I mean the worst. So another thing I also really want to rewrite is, of course, the types, because the types kind of suck right now. I'm not too sure how to describe how they suck, but it's like my perfectionism won't allow it. I could, like, definitely improve them to be way better. And while I feel like they work fine, like, early in development, as Crescent is right now, and I need to realize that, like, hey, it works fine right now, you can update it later. Like, I have a lot of stuff that I want to add into Crescent. Like, one thing I've been playing around with the concept of is, like, or the idea of is, like, signals. Though I'm not too sure how I'd implement that. Another thing I like wanted to add, or thought of, not really wanted to add, just kind of thought of like, hey, this is a thing. Not too sure how I'd implement it, or if it'd even be good or useful, is like a way to quote-unquote protect variables, where like variables could only be modified by a certain function. I think I want to make Crescent kind of like a math-focused language. Like not explicitly math-focused, but like there's like a lot of like mathematical stuff. Like later in development, add like matrix types and stuff like that. But another thing I feel like I can improve from Lua is strings. As like strings in Lua are like pretty like well known to be like not that fast. And I get a reason of this is because like, well, not a reason, like pretty much the reason that strings are like that, and actually in many other programming languages are the same, is because like strings are immutable. And specifically the reason why Lua strings are immutable is because rather than allocating 2 memory blocks for the type body and the actual content of the string, what Lua does is uses a flexible array member at the end of the struct, and has the size of the body plus the length, or the length plus 1, or like the size. So the size of the string body plus the size of the content. And you can't just like resize the type body, because that would require you to update all references to that pointer, which you can't do. So rather instead, you just like, wait. Okay, I'm actually... Does it create a new one? Or does it like... I know it creates a new one, but I don't know if it immediately destroys the old one, or leaves it to be collected by the garbage collector. But anyways, I want to make strings immutable, so that requires 2 separate bodies for the type body and the string contents. Which, yeah, double the number of allocations, but like it definitely could make strings faster. And not having to reallocate every single time like a string is like concatenated to. It would like dynamically resize the content, and like actually like add a bit extra when resizing, such that it's not like constantly resizing. It's like create. There's a bit of vector space. You can concatenate some stuff. Concatenate. All right, we're out of space. Let's resize. Concatenate. We're out of space. Let's resize. And yeah. Oh shit. And although I really do like zero indexed arrays, I feel like I'm gonna make arrays and crescents one indexed. And this is again because of the math focus I want to have on the language. And math is usually indexed arrays at 1, or lists, I think they're called in math. But anyways, yeah. And I feel like it could have some benefits actually though. While it's not conventional, I feel like it could like prevent like some off by 1 errors. While everything written below about GC value is valid, it has values when implemented and makes everything more complicated than necessary. Everything written beyond this will ignore GC value. Yeah, GC value sucks. And that's also why I called it GC value earlier. Like, by early I mean like 40 minutes ago, rather than 40 minutes ago, rather than how Lua calls it GC object, because it's a union and not really, because it's a union, and I thought value was a better name for it. Another thing that I've been working on is like virtual machines, because like I've wanted for a while. I've wanted to like develop my own like very like minimal testing kernel, and the thing about that is that hardware standards are like, they're messy and like hard to understand. So my solution was like, why don't I just like develop my own virtual machine with my own like BIOS interrupts and stuff like that. So I can then use that to develop my kernel. And it would probably do me more to like actually learn hardware standards and then go from there. But then again, making a VM is also really cool. And I've been trying to like make like the bitness of it is specifically like 16 bits. Because that just makes it easier to make, I guess. But yeah. So 16-bit VM with absolutely no memory protection. And although there's no like, and there's not even like the 20-bit address space. No, it's only 16 bits, so you only get like 2 to the 16 bytes. I don't know why that took me. Or like 65,536 bytes of total memory. 25% of that from 0 to 0x, I think 3FFF, or 1638. So 16,384 bytes, or 25% of it from 0 to 0x3FFF is the code or text segment. It's not really a segment because it's only defined in the code. But yeah, and then the bytes after that from 0x4000 to 0x7FFF is another 16,384 bytes, which is the stack. And then the final remaining 32,768 bytes from 0x8000 to 0xFFFF is the heap. And it's not going to be like a really complex heap that I want to make. It's just going to be like a simple one. I don't. I think that's really cool that they put that there.